All right, so we are in week 7 where we are learning about exponential and logarithmic functions. So we are almost done with the class. We've got this week and then one more week, and then you guys are done. You're ready to move on to pre-calc or yeah, there's definitely a lot of calculator stuff in here. So you're definitely going to need your calculator handy for this week. So we're covering all of chapter 5. So 5.1 is exponential functions and their graphs, and then 5.2 is logarithmic functions and their graphs. So exponential functions and logarithmic functions, those are inverses, so they undo each other. So that's why we're looking at them together. Then 5.3, we are covering properties of logarithms, and that is what I'm going to be doing my live session on Saturday. Today's Wednesday, my brain. I'm doing the session on 5.3 Saturday at 2 o'clock. So the properties of logarithms are basically all the rules that work with logarithms and how to simplify and expand. And a lot of people struggle with that. So that's a good one to attend if you can on Saturday. Then we've got 5.4 exponential logarithmic equations. And I have a video on that in the instructor videos. And 5.5, which is exponential logarithmic models. And there's a video for that section as well. So after Saturday, there will be videos for 5.3, 5.4, and for 5.5. It's just not for those first two. But those first two is graphing, so you can use Desmos for that, and that will make things a lot easier for you. So this week's material I really enjoy because this actually shows up a lot in real life. So bacteria growth, population growth, anything where something is growing usually grows exponentially, and especially with populations. So exponential functions are used in any kind of growth of that way. Logarithms are used for radiocarbon dating, pH, earthquake magnitude. So that's sort of like the reverse as things kind of decrease or decay. That's usually where we use logarithms to kind of find those results. Interest and bank accounts, depending on the type of interest, that's usually exponential. And then estimating time of death. So people who are in the criminal justice field, usually they have a shortcut to determine time of death, but where the numbers come from to give you a good estimate actually come from Newton's law of cooling, which is an exponential function. So there's a lot of stuff in real life where this thing occurs, where these pop up. Newton's law of cooling I've actually used to determine how long I need to cook a turkey for Thanksgiving. So most people just follow the directions on the turkey, but if you really wanted to, you could actually use algebra to figure out exactly how long that turkey needs to be in the oven. So that's pretty neat. So this week, the things you're going to be doing a lot more factoring as always. There are asymptotes when we talk about exponential and logarithmic functions. So you're going to be looking at asymptotes again. You'll be solving linear and quadratic equations. You'll be doing some graphing. And we haven't really dealt too much with the properties of exponents since we were basically multiplying polynomials. And so now you're going to be working with those properties of exponents again. So I believe that was P.3. So if you don't quite remember those, you may want to go back and review P.3 to refresh yourself on all of those properties. Those will be really handy at the live on Saturday because the properties of logarithms are based off of the properties of exponents. So reviewing that is going to be handy. So this week you've got your discussion, your ungraded practice assignment, your assignment, and then your quiz. And this is the very last assignment that you have to do. There is no assignment in week 8. I want you to spend that time to focus on the midterm. So this is your last assignment. So let's talk about the discussion. So one of the things that you learned this week is about Euler's number, which we use the letter E to represent. So we generally don't use E for a variable because it actually is a specific number. It's about 2.718, I think, is what the number is equal to. It is a number that goes on forever, just like pi. You guys know that pi is 3.14, and it has millions of digits. So that's another special mathematical constant. And so pretty much everybody's already familiar with pi. The book tells you about E, and so this is a good place to get into a discussion about what other mathematical constants are out there besides pi and E that are special. And there are actually a lot, but most of them are used in applications. So there's a lot of constants that are used in physics, such as the speed of light, or in chemistry, you've got Avogadro's number. And there are other types of sciences. There are constants that are used in electrical engineering. There's ones that are used in mechanical engineering. There's all these different constants out there. And it's actually pretty interesting to learn about all of them. I have made a video on the square root of 2, which is called Plato's constant, or no, Pythagoras's constant. And I'm going to be posting that in the discussion sometime this week, so you can see the little video. The history behind that one is really neat. So this is a research-based discussion where you're just going to find some information about math in the world, basically. So your goal is to do a discussion. You're going to be researching a mathematical constant. And what makes something considered a constant is that it generally has a name. Like E is called Euler's number. Pi has a name. I don't remember what it's called, but it does have a specific name. So there's like speed of light is even considered its name. You know, it has a name to it. A lot of constants are actually named after people. So you're not going to just research any number like 0 and 1. Those are just numbers. You want to have something that has a specific meaning to it, maybe has a specific name, like it's named after someone. And what makes it a constant is that it actually is a number. So you don't want to look up something like a prime number because there's not just one prime number. That's not a constant because there's lots of prime numbers. So you want to look up a specific number that has like a name to it. So you're going to do research into these and make sure you write down all of your sources, because whenever you do research, you have to share your links. And then after you learn about the constant, you want to summarize what you learned. So don't copy and paste. Explain to us like you were explaining to a friend or telling somebody, oh, this is how I learned. Like when you tell someone about a movie you saw, you don't quote the movie. You summarize the movie. That's what you need to do with your research. So some specific things is to talk about the history of the number, maybe who invented it, who named it, when was it discovered, when was it named, some facts, some cool facts about it. I mentioned the square root of 2. That has been, there is a myth. It's not, I mean, it's pretty much thought that it's a myth and not actually true, but there is a story that a Greek got thrown overboard and killed because he discovered the square root of 2. So that's, you know, some interesting facts about that, those kind of things. Those are, you know, fun stories like that you can share. And then how it's applied or used. Is it used in a formula? If so, give us a formula. You know, what topics is it useful for, that sort of thing. And then include those links that you wrote down, because you do need to include all of your links every time you do research. So there are a couple links in the discussion to help you out, but some constants are harder to research than others. So I have a list here of constants that I recommend you choose from, because these are a little bit easier to understand than some of the others. So tau, speed of light, the speed of sound, Chaitin's constant, Avogadro's number, Planck's constant, Hubble's constant. Graham's number is really cool. That number is so big we can't actually write it, so we don't write that number at all. So that's a cool one to research. They've got the Franson-Robinson constant, the Euler-Mascheroni constant, Brune's constant, absolute zero, the Chandrasekhar limit, Boltzmann's constant, the golden ratio. That's one that a lot of people pick. Gelfand's constant, the ideal gas constant, gravitation constant, Meissel-Mertens constant, Landau-Ramanujan constant, the plastic number, the fine structure constant, and then Capricar's constant. Capricar's constant is the one that I learned about recently when I went to a talk in March, and it was really cool. So I recommend you choose from this list, because it's going to be easier to find information from. and about, and these are going to be a little more, they'll you know, that you'll be able to understand these. Now, if you are researching and you find a source and you don't understand what it's saying, don't use that source. You want to find sources that you understand what it's saying. So if you don't understand it, then you need to try somewhere else. And if you're struggling, let me know. YouTube is actually a good place to research some of these and find out some information on. So don't just look for websites, look for YouTube videos. There's a lot of them about some of the more famous ones. So that's a good source that you can use. And if possible, try not to pick one that somebody else has done, because if everybody's doing the same constant, it kind of gets boring. But I know that some people, you know, you are going to have some overlap. But if you can try to find something that somebody else hasn't done, that's a cool thing. And you're welcome to choose other constants that are not on this list. Sometimes people do that, and I'm like, oh, I didn't know that one. Let me add it to the list. It's pretty cool. So when you're writing your discussion, definitely make sure you start out with the name of your constant and then what its actual number is. So you can say, I researched pi, which is equal to 3.141592, and goes on forever, or something like that. So because sometimes I see people and they don't actually tell us what the constant's equal to, what the number is. So you want to make sure you tell us that up front. Or sometimes people don't even tell me what constant you researched. And I'm like, well, wait a minute. What is the number you're looking at? Describe its history, who discovered it, who named it, was it named after somebody, what year was it discovered, those sort of things. Explain how it's used in the world, if it's in any formulas. Tell us any cool or facts you learned while researching. So that's the kind of things that you can put in your discussion. And then for your replies, you can talk about what you found interesting about the post from your classmates. And then if there were, like if you happen to research the same constant and you found information they didn't, then you can share that information. Or if you just happen to know some information about the constant. Like I've seen some people research one constant and then somebody else is like, oh, I actually use that in my job. Here's how, like things like that. So this is a pretty fun discussion. A lot of people enjoy this one because they're just learning new things about math that you may not have thought about. So do you guys have any questions on the expectations for the discussion for this week? Okay. No, you don't have to solve anything for the discussion. This one is just research. So there's no solving. You don't have to work out any math. If you want to, you can. I mean, some people will work out a math formula demonstrating the use of their constant, but you don't have to actually work out any math. And you don't have to for the week 8 discussion either. So last week's was the last one where you have to do that. Yeah, it's the discussion is really not as bad as it may sound, and I think you'll really enjoy it. I usually try to share some videos. Like I went to the Museum of Science and Industry in Chicago last year around Thanksgiving, and they actually have a math exhibit. And so I went to the math exhibit and I took a whole bunch of videos because they talked about the golden ratio and things like that. So I usually try to share those in the discussion this week. If you're ever in Chicago, I do recommend going to that museum. It's pretty cool. The math exhibit was fun, and it's not, I mean, there was tons of kids that they had a blast in the exhibit, so it's not like it's over your head or anything. So for your assignments, you've got your ungraded practice assignment, and so these are odd problems chosen from chapter 5. All of the answers are available to you, so you can always check your work. And then you've got your graded assignment to work through, and you can always email me if you have questions on the graded assignment or you need some help. And then your quiz this week. So the quiz this week is going to be on last week's material, so it's going to be covering week 6 stuff. So by Friday at the end of the day, sometimes by Saturday, I can guarantee that all of your week 6 assignments are being graded, so then you can take a look at where your errors are. Because basically you're going to be doing the same thing on the quiz. You'll be looking at the domain, the asymptotes, the intercepts, the zeros. You're going to be graphing them, looking for shifts left and right, which help when you just have Desmos. So the quiz for this week should be pretty straightforward, very similar to the assignment. And to study for the quiz, I only have one link here, which is on rational functions with their asymptotes and excluded values, just because that seems to be the hardest part for people. So you can use that to do some practice. But usually people do pretty good on this quiz, because usually week 6 isn't as bad. So that's the quiz. And then, so the suggested schedule. So you can do a section a day as usual. And then I've pulled out which practice problems go with each section. So there's like 9 or 10 problems in each section. Here there's only 5 for 5.3s. And only one that really goes with 5.5. The assignment is not in order. So question 1 actually goes with 5.4. And then it goes 2, 3, 4, and 5. So just as a note, if you try to start from question 1, you're not going to know what to do because that actually goes with 5.4. So just pay attention to that. And, you know, it takes some time to resubmit work. If you have missing work, it's week 7, so we only have a couple more weeks left to get in missing work. All 8 missing work resubmissions have to be done by, let's see, Tuesday, December 3rd. Once the course closes, I can't accept any more work. So you've only got a couple weeks left to get in anything that's missing, to do any drop boxes so that you can remove the penalty on your quiz if you didn't do the drop box, that sort of thing. So do you guys have any questions? Just to reiterate, Saturday 2 p.m. will be 5.3, and then because last night's Q&A that I did people seem to enjoy that, so I'm going to do another one next Tuesday, same time at 7 p.m., where you can just pop on and off at any time during the hour. I will be there. You can even just sit at your computer working out through the homework and then ask me questions if you want. You know, kind of treat it like I'm just there to help you out of your questions sort of thing. Or if you want to just chit chat, we had some fun chit chatting last night. And I'm happy to if you have something you want to talk about or you just want to tell stories and nobody has any questions on that, that's fine with me too. But that was fun last night, so I'm going to do another one of those next week. So if you guys do have questions, of course, you know how to reach me. And yeah, that's all I've got for you guys. So I hope that you guys have a great Wednesday, and hopefully I'll see you on Saturday. And enjoy the rest of your day. All right?